So as what I've mentioned, the first part of the discussion will be allotted for compound amount at the fraction time. So meaning T is not exact time here. So when I say not exact, so T are not equal to whole numbers. Okay. So we'll just work on the two problems presented in the module, but you might be wondering there is discrepancy of the answer because of the rounding off thing done along the process of computation. Now, there are also two methods presented in the module. So if you prefer those methods, that will be fine. And then I'm going to present another one. Actually, uh, the one of the methods presented there is just the splitting. No, the given was divided into two parts, but basically it's exactly the same. Okay, so working on the first problem here. Okay, and this is the formula that we're going to use. For S is the accumulated value, that's the final amount. Then P is the present value. The I there has to be in small letters, so that's the interest rate per period. So take note that small I, is equal to the annual interest rate, and we'll divide that by the compounding period. Let's denote that by J. Okay. For example, in this problem, our J equals 2 because it's compounded semi-annually. So when we say semi-annually, it's semi-annual. So semi meaning dividing the period by 2. So semi-annual means 6 months, and there are 6 months in the year, in the fiscal year. So our J equals 2. And take note that the annual interest rate has to be divided by 2 to come up with the I there. And the problem states that we are asked to find the compound amount if 10,500 pesos is invested for 4 years and 3 months. Again, T here equals 4 years and 3 months, right? So we have to convert this to its equivalent fractions. And we know that there are 12 months in a year. So 3 months over 12. So we have 4 and 3 over 12. To its lowest term, this is 3 and this is 1/4, right? So this would, in equivalent decimal value, T will be equal to 4.25 years for a while, guys. Okay, so we now have T equals 4.25, and we know that the present value in the problem is 10,500. So we'll just substitute the given in the problem. So our S equals 10,500 quantity 1 plus, it's 7%, so it's 0.07 all over 2. And then that's our N equals the product of T and J, the compounding period. So here, T equals 4.25 times 2. So that's 8.5, right? Okay. So it's 8.5 to the 8.5 power. Now using your calculator, so you'll come up with this value. Now, some of you along the way, now in the module, the step-by-step procedure is provided, so that's fine. For me, whenever I upload your next activities pertaining to 2.2 and 2.3, I'll just have you to identify the given and then substitute the given in the formula, then your final answer rounded up to 2 decimal places. So I'll give consideration, of course, for discrepancy of values, but of course we know that the discrepancy, of course, will not, go far beyond. Okay, so it could be in cents, or of course I'll go back to your resolution. But for this one, we have the accumulated value equals 14,066.38. So there must be discrepancy between the value presented in the module, but it's the same, no? So a little difference only. Okay, so it's still working on the accumulated value at a fraction time or fraction of a period. This time, let's proceed with the second example. And we're still going to use the same formula. So this time, we're going to find the compound amount. If 7,200 is invested for 3 years and 9 months. Again, T is fraction. And T equals 3 years and 9 months. Okay? So, of course, we have to convert this into years and convert 9 months to year. So, that's basically the idea. So, this is like 3 and 9 over 12 years. And this equals 3. Well, it doesn't matter whether you present your answer in fraction form or in decimal. Okay lang, as long as they're equivalent, of course. So, this is 3.75, right? Okay. Now, we know that our I equals 0.08 divided by, again, it's compounded semi-annually, this is 2. And then our N is the product of the time, which is 3.75. And again, 2. Okay? So we have N equals 7.5, right? So substituting the given, we have S equals 7,200 times quantity 1 plus 0.08 all over 2 to the 7.5 power. And then using your calculator, we'll have x equals 9,662.35. Well, this is kind of easy since, again, I told you I've presented or discussed already with you. We're done with compound interest. We just get back to this, emphasizing or working on t not equal to whole numbers. So let's go back with present value. This time, again, t is in fraction form. So going back with the formula, so this is solving for the present value. You know what's S already. And then take note that the exponent is negative n. And I've also shown you an equivalent formula for this. So whether you use that or this, it doesn't matter as long as you'll come up with the same correct answer. So here, uh, t equals 5 years and 5 months. So this is equal to 5 and 5 over 12. And approximately that is equal to 5.42, right? Okay. It's 5.42 here. 5.42 years. And our n here equals t 5.42 times this time compounding period is 4 because this is compounded quarterly. So there are 4 quarters in a year. That's why. So we'll multiply this by 4. So we'll come up with 5.42 times 4, we have 21.68. Okay. And then we have P here equals 13,400 times quantity 1 plus this is 0.12 all over 4 to the negative of n. So this is 21.68. Well, I must admit that the answer here is an approximate value. So using your calculator, you'll come up with P equals 7,059 and 82 cents. Okay, there. And one more example for present value with T is a fraction here. So find the present value of 29,650 pesos due in 3 years and 7 months at 8% compounded, again, semi-annually. So with T equals 3 years and 7 months, we have T equals 3 and 7 over 12. And this is approximately equal to wait, I'll check. This is 3.58. Okay. So we have our T equals 3.58 this time. So we'll multiply that by 4, or rather 2, no, to obtain N. So N equals 3.58. This is 5 times 2. So 3.58 times 2 give us, wait, 7.16. Okay. So this is 7.16. And then your I is 0.08 divided by 2. So we have P here equals 29,650 times quantity 1 plus 0.08 over 2 to the negative 7.16. So here, your P will result to, let's check. You check also. So again here, P equals 3 years and 7 months, approximately equal to 3.58. And then N equals the product of time and the compounding period. So we get 7.16. And then we round off the value to solve for P. So substituting the value, we come up with this value